2016 season. We're really excited to kick off the winter webinar series here at EdTech Teacher with coding. As many of you know, next week is the Computer Science Education Week, and for a couple years now, Code.org and Hour of Code have created an initiative to try and get coding into schools just for an hour and take those initial first steps and sign petitions and have everybody doing it at the same time to create resources and a conversation around it. Last year we talked about how to get started, and today Maggie Keeler and I are going to talk about how you can get into coding and start bringing coding in the classroom in a different way through digital storytelling. So a little bit about myself. I'm the web coordinator and marketing coordinator for EdTech Teacher. So the website that you're on right now, the social media, and all of that is something I've done. And I'll tell a little bit about my story in a couple minutes, but I'll let Maggie introduce herself.
Hi everybody, Maggie Keeler. I'm also out of Massachusetts. I'm originally a high school biology teacher, but have also worked with science teachers in a variety of different settings, and primarily focusing on biology, but also other STEM and STEAM aspects. So I'm not a computer science person, but am really interested in coding, and this particular topic became of interest to me actually working with my own kids who are 9 and 7, who showed me that they were starting to think about coding through telling a story rather than through the actual language. So I'm excited to be here with you guys today. Back to you, Kate.
Yeah, so we will get started. Let me just share my screen here. Can you see that?
Yes.
Okay. So these slides are also embedded on the bottom of your screen, and they will be posted and free for you to use and share. So, and as I mentioned just now in the chat, please feel free to jump in at any time. So, Maggie, correct me if I'm wrong. This is your daughter actually made this, or this is from another?
This is actually from another example that I found from an elementary school teacher who is working with her students on coding and stories. This is actually from Scratch Junior, and the reason I had shown that one was just because it's actually the students' individual drawing, so they created both the characters and then coded the animation through the characters.
Is it playing? No. Let's see if I can get that. Do it quick.
Let's play hide and seek.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ready or not, here I come! Found you!
So that's just a quick and easy way that you can just, all you are is telling a story, but that story had to be laid out, and using these coding apps that we'll show you, you just learned to code.
Hi everyone, how are you today?
But,
welcome back to
cool.
Ashton for.
Sorry. This one actually is a little one that my cousin created on Thanksgiving. I was showing her the Scratch Junior app, and she thought it was so cool that I drew my dog, and she wanted to also make one. So all she did was create these interactions where when people bump into each other, then this pops up, and then the dog walks across the screen. So we're going to show you a little bit more of how you can do this. But first, I sort of wanted to talk about a little bit take a step back of why we should be teaching coding in your classroom. Obviously, you're all here tuned in because you have interest, and you probably think that there is a value to this. A little bit about me. I actually was in a one-to-one laptop program in 1999, and this was my computer. It was called either the clamshell or the toilet bowl, but it was the first laptop that it had a handle on the back of it, And my class was actually in a pilot program that was being studied against a control group to see whether or not our grades would be any different. But in reality, in the end, nothing really changed. We had the same grades. We were, instead of taking notes on paper, we were taking them on a laptop. Instead of doing research in the library, we were doing research online. Instead of passing notes, we were using AOL Instant Messenger. So really not a lot changed, but what did change was they only did this, we were in a trimester system, and they only did it for the first 2 trimesters. And for the 3rd trimester, we took different classes, and you had the ability to choose your own elective. And all the kids that took the laptop pilot program, we signed up for computer programming, and we still took our laptops to class, and we were trying to figure out new ways to just use these devices to bend them to our will, basically. Instead of being sort of shoved in the curriculum as they were, we were sort of making the curriculum work with them. And I think in a semester, I took a programming class. We learned a programming language. Just like languages of the world, computers, there's different ways to program a computer through different languages. And I was in C++, which is almost obsolete now. And all I did in the entire year is make a red ball bounce across the screen. But I was thrilled about it. I loved it. I went home. I was sharing it. It was not that big of a deal, but I just really loved it. Unfortunately for me, I actually transferred schools. My dad was in the military after that year, and I ended up going to a school where we not only did we not have a pilot program, we didn't really even have any type of devices or technology at all. It was actually, you weren't allowed to have anything. Cell phones were banned. Everything was banned. There was one small computer lab in the corner, and apparently there was a computer science club, and I went there, and it met during lunch, and it turned out it was sort of just the place that a couple of nerdy boys wanted to hang out during lunch. So I basically quickly got out of there. I wanted to fit in. I was 15, and coding wasn't cool. So I basically turned my back on that great experience. And then when it came to choosing where I was going to college a couple years later, I didn't know what I wanted to do. And my dad, who works in IT, did point out that, hey, you loved it. You when you were doing coding back in the day. And I just basically said, no, that's not cool. I don't want to do that. I want to go off and be an architecture major. So I did. And then I took a very interesting path because I ended up studying abroad in a school that I loved. So I went back and worked at the school. And in my senior years of college, I took 2 or 3 computer science classes because I was a math minor, and it was a requirement to take 1 class, and I waited until my senior fall to take it, and then I fell in love with it again. My passion was woken up again. I was a varsity athlete, spending my days in the back of the van programming because I didn't care what people thought. I actually really liked solving problems. And then I ended up working in schools, and I ended up working with teachers and helping them learn. And then I self-taught myself how to create websites. And that's sort of how I got to where I am today. And I tell you this story because I'm not alone. There are a lot of kids out there who their brains would thrive on this logical ideas, and we're giving them really powerful tools. And we also know that there's a lot of these numbers out there, and I hate to always focus on the numbers, and I'm just going to kind of go through these quickly. They're all from code.org, but it's basically saying that there are 1.4 million computing jobs, and we're not filling those jobs. There's more jobs, and we're not filling them because we don't have the workforce to fill those jobs. Less than 2.4% of college students graduate with computer science, and that number is actually dropping. Not as many students are taking them in AP classes, and minorities are even smaller in that small minority. And gender is another huge gap. When I worked in an IT office, I was the only woman out of 12. And why is this? Well, one of the reasons is because 9 out of 10 schools don't offer computer programming classes. And many states, the one's a little outdated now, don't even allow you to count computer science towards high school graduation science requirements. But what does that mean? What that tells us is that computer science isn't valued as much as the other sciences and humanities. It's an elective. It's not important. So therefore, it doesn't get a focus in a lot of curriculum. So how are these ways that we can now bring coding into our schools if maybe there's just not the opportunity just yet? Maggie, do you want to talk a little bit?
Sure. One of the things that when Kate and I first started talking about coding together is I really was bogged down initially thinking about syntax and how I was going to go through teaching this. And let me go ahead and screen share my.
I can also just click through it for you.
I can do it here. And realizing that I, as not coming from it, not as a computer science major or even someone who had taken computer science since, I believe, my sophomore year in high school, bogged down with this idea of how could I teach it if I didn't know the current syntax. But really, when we start looking at syntax, the reality is whatever language we're going to teach our students right now, it's very likely that that language will be obsolete. Just like Kate was talking about, the C++ is really not used anymore. So feeling like you need to understand the syntax before you can actually teach coding, I think, is really something that's a stumbling block for a lot of teachers. But in reality, the syntax is only a very small part of it. It's really about teaching students how to think through the process of programming and what's involved in giving those sort of instructions. And you can do that without having any sort of basis on the syntax. And really, the syntax can come much later as far as the students are concerned. And one of the things I really like thinking about is when we started talking about this is that you can even do a lot of coding without a device. You can do what's called coding unplugged. And there's a great website through thinkersmith.org that gives you a whole slew of different activities that you can do in terms of how to get kids thinking about coding and the process in an unplugged manner. And one of the great activities that Kate likes to do, and I've done with groups as well, is this idea of what are the steps to making a PB&J sandwich, and how would you go about programming a friend and telling them how they should make a PB&J sandwich. Kate, do you want to talk through how you sort of do that with students?
Yeah, so a lot of students, you start by just sort of getting the ingredients for PB&J, or in the cases, or soy peanut PB&J if you have allergies, is you just get the ingredients and you sit in front of the classroom and you say, okay, kids, let's everybody write down the steps to making a peanut butter and jelly sandwich. And you have them write down these steps, and then when you collect them all, and be prepared to get messy, pull one random one out and do what those directions say step by step. So if it says put the jelly on the jam, just grab the jar and put it on top of the bread. You're going to try and overly assume nothing and show that it's really important to create steps that are logical, because a computer doesn't know how to interpret. It needs to start with the very basics. And then I normally actually have the kids go back and not just rewrite their directions, but do it in small groups and show the power of collaboration and thinking about how different people think about steps and how different people approach different problems. There is no right or wrong answer, as long as at the end of the day, you have this delicious peanut butter jelly sandwich. And that's a fun one just to sort of introduce coding in general, especially in these classrooms that sometimes are like, well, I don't have time, I don't have devices, I don't have any of this. And it's just a fun way to get kids sort of through it, because in reality, a lot of kids don't actually know what coding is and what programming is. Computers just have been so ubiquitous to them that it's just this device that works, and there's the idea of this programming, but it's sort of very abstract.
Hey, you just mentioned a great thing I wanted to pull out. I often get asked, and I'd love to hear your opinion, what's the difference between coding and programming as far as you're concerned? Because in that last description, you use both those terms, and I think it's often used interchangeably, but some teachers aren't sure if you're talking about the same thing.
When the way I define it is, I'm sure you'll have different people have different opinions, but I kind of regard coding as just sort of the science of logical thinking for technology. So coding is, I am coding you how to make coding is creating that peanut butter and jelly sandwich and the steps it takes to get there. While programming is sort of the language specific technical sort of, whether you're going to use C++ or HTML or PHP, or in the case of the peanut butter and jelly sandwich, pen and paper to read your directions in English. That would be more the programming, and coding is more of the idea of programming. I'm trying to remember that great analogy I've heard before, but if it comes to me, I'll bring it back up.
No, thanks. I didn't mean to interrupt you, but I think that's what
no.
often comes up.
So another unplugged activity that we love to do is it's called Robot Friends. So you do this in pairs or the groups of 3 or 4, and in one spot you pick, in one group you pick the robot, and the rest are the programmers. And then what you do is all you need is some solo cups, and you start with the solo cups stacked in front of you. The robot does, and you tell the robot that you have a claw. And the only thing that you can do is go, if you go to the next slide, I have an illustration of it. The only thing you can do is move the cup up. You can either pick the cup up 1 cup height, or put the cup down 1 cup height, or move back and forward. And the way you do that is you get programmed by your programmers, who need to then try to make this shape by just giving you those 4 commands: up, down, forward, and back. And you can either have students do it verbally, but I prefer that it's also a verbal and a visual. So if you go to the next slide, you'll actually see this is what the program would look like to make that shape of 2 stacked cups or 3 stacked cups. And I could actually, I was just doing this with a group of students. So if we go over to screen share, can you see me?
Yes.
I can angle my screen here and show you that this is what it would look like, where you would have, if I was the programmer, you would say, and we had that slide up there, to make that shape, you can go up, angle my screen a little bit better, up, over, down. And then the trick is you have to also program the claw to go back, pick up, forward. Sorry, my screen's a little close. I didn't put those too close together. And then back, up, forward, down. Stack my cups too well. But that's generally how it would work. And if, as you can see in the, I can go back to the slides. Which one did I have the slides in? Sorry, I lost my slides. Oh, they're there. So you get students to start with this very basic screen down here. So you give them the shape, and then they have to program what it is. And you can do this where you can even say it has to be silent. You can have it, kids talking through it, and then you can start to make it more challenging once you do other ones. So you can have to go, you'll have to stack higher, and then you can even add in another challenge where flip cup over and make new shapes. That thinkersmith.org actually has all of these icons for you to make shapes. They have lots of them. You can even get interesting, and in front of me right now I have those aqua cups, but I also have pink, yellow, and purple, and you could make these colorful, and you have to then say pick up red cup, blue cup. So you can start to add more complexity as you start to do this, which is exactly what coding is you're adding more complexity. So this is just, and you haven't even touched devices yet. So this is just another way you can bring in coding into the classroom.
We had a couple of good ideas from the chat wing as well. Colleen told us that using fluff and jelly for those allergies, which I'm sure kids would love the fluff idea. And then Kathy was also talking about using having her students program her to make her get from the classroom entrance of the classroom all the way to her desk. So there's some other great ideas for how to get the idea of coding without the device.
And that's a nice transition into these other apps, like Kathy getting programmed through the classroom. There are also these games that are the same way, where you have to lay out the steps to, this is Codable and this is Lightbot, to getting the robot or the little guy around the course to get the right things, to get the ideas. And there's lots of coding games out there where you're learning these principles of logic and step-based and repeats, and if this happens, then that happens, and sort of thinking through the process before you've ever actually started talking about that syntax. Matt, you want to talk about the design aspect?
Sure. So I think you need to scroll through a little bit further where I'm just seeing syntax slide right now.
Oh, I'm on the wrong. Sorry, let's try moving through the wrong screen. There we go.
The danger of the multiple windows.
Yeah, I know.
This one,
screenshot of the games.
Yeah, and those are great if you've already done the idea of moving on the floor tiles. It gets them this idea. Another really nice way of introducing design or coding is through the concept of design. And there's a wonderful website madewithcode.com, which introduces a whole series of different project ideas. These are really more geared for probably your middle school, high school, or even beyond in some cases. But just this idea, this is a dress actually, that the light pattern of the fabric lights up and flashes in different patterns based on a chip that's been programmed in the dress. There's different ones for, some of the shoes that you have that do the flashing and that sort of idea. But just this idea that you're coding not because you're creating a computer program, but you're coding because you're trying to design a product, design art. But it can be a really great segue for some students to really hook them into the idea of coding, particularly those students who kind of see coding as something that might be kind of dry or dull and just based on syntax and computers, but this idea that you're really bringing it in from a very creative point of view. So I would encourage you to explore this website if that's something that you're interested in. You want to do the next slide? One of our, I think, both of our favorite quotes here is Mitch Resnick, who is at MIT and a co-creator of Scratch, which is a program that I know many teachers use with introducing coding and getting quite deep into coding with their students, is this idea that you don't just learn to code, but you can use coding to learn. And that coding can be a process that can help you learn not just the art of coding and programming, but that you can use coding to help you learn science. You could code simple games or simulations that would help you explore scientific parameters. You can use coding to help you learn math. You can use coding to help you learn Spanish. You can use coding to help you learn storytelling. And so coding can just be the medium by which you're learning the various skills, or the media by which you are demonstrating your understanding. I love this quote through two researchers out of the University of Pennsylvania, Burke and Coffey, who did an exploration on digital storytelling and coding. And this idea that the importance of sequence, structure, and clarity of expression, these are all three aspects of characteristics of effective coding and good storytelling alike. So if you read a good story, it's got a great sequence of events. It really draws you from one scene to the next. The structure and how it's written is really well developed. And you need to have those three elements also if you're going to have effective coding. And so just that there's a lot of similarities between coding and the digital storytelling process. next move, do you want to hand it over to me or you want to do it?
I don't mind doing it.
Okay. So this idea with the digital storytelling really sort of came out of the writer's workshop idea that was created in the early 90s. And the writer's workshop really emphasized this idea of taking the process of writing and moving it from this solitary idea to something that's a communal process, that you're working together to create a product in your story. And there's peer editing, and you're really not doing this alone. It's also really focusing more on the process rather than a single product, and that the writing process and how you go through pre-writing and editing and crafting the story is important. And really also looking at what you're writing as a means of personal expression. And digital storytelling, if you just add into the mix, is basically, I believe with click, there's a reveal here somewhere, is you're adding this unstandardized format. So digital storytelling can be a video, it can be a podcast, it could be a coded animation that you created to express your story. And it's just providing students a variety of means of expressing themselves. And if you look at this idea of coding and digital storytelling, I think coding, some of the language barriers that happen with students when you start introducing ideas is they're unfamiliar with a lot of the terms of sprites is a term that if you've done anything with Scratch, you're familiar with the idea of the sprites or the characters that are moving during the animation. But if you talk to a student about a sprite, they're probably thinking you're talking about the soda that you might drink. But if you start talking to them about a protagonist or an antagonist, or who are the actors in the story, or who are the characters in the story, those are language that they are very familiar with, particularly seeing as this writer's workshop is really, come down all the way into the kindergarten and first grade. And so they've been working with this throughout their elementary school. If you look at the writing process of the drafting and coding, we're talking about the design process. Or in writing, you talk about revising your story. In coding, you're debugging. But it's still the same idea, is that you're going back, you're editing, you're looking for problems, and you're solving those problems to make your code or your story better. In writing, you've got these character motivation. Why did the dog decide to run away? Or, why, what motivates the characters in your story. In coding, you're talking about the coding parameters. But if you start out with students and talk about coding parameters, those are familiar terms they're not familiar with. But if you couch it in the terms of character motivation, it's something that they're already very familiar with. So if we start looking at how you do this and how do you teach coding through digital storytelling, there's a lot of great resources out there if you're interested in it. But this whole idea really starts with this pre-writing and pre-planning process that we're all familiar with from writing. And this idea that of early on, this takes largely in the coding process of character development and setting. So who are your characters going to be? How are you going to personalize those characters? What are those characters going to, why are they in your story? And then what's the setting for your story? And how are you going to create that setting? And these are just two examples. One on the left is Tinker. Tinker is available app that's available for iOS as well as online, so you could use it on most devices. And the one on the right is Scratch Junior, which is an iPad app. And both of these enable you to personalize or create your own from scratch characters that you can draw, like our very first example of the girls playing hide and seek. And you can also have settings that they've developed, and they have sort of a certain preset number of them, or you can create or draw your own settings. So students have a lot of flexibility in how they do this. And one of the great things about Scratch Junior or Scratch on the computer is that you also can bring your own yourself in as a character for your stories, which is a really great motivator for a lot of students. Once you've done that pre-writing and pre-planning, you're ready for the drafting process. And for a lot of students, they want to jump ahead of this process, but it's really important for them to do that outline or the storyboard. And we'll post the these slides later, but you'll see here there's a link here to free storyboard templates. So you have a wide variety of templates that you can download as a PDF for your students to work with. But this picture actually is one that I shared because this is actually my 7-year-old son created. He wanted to work on a monkey book. And he is a writer, but an early writer, and I told him to create a storyboard for it, and he drew out his stick figures of his storyboard. So he had planned out his 9 scenes that he wanted to create as part of his story. And you know, this very simple sort of stick drawing can really help students as they organize their thoughts, as they plan what their characters need to be able to do, so they understand what sort of problems they're going to need to figure out how to solve within their coding, what sort of scenes they need, what characters they need. And it also really helps them in that planning process of their story as well as the coding process. Once they've drafted their outline, then it's time for actually doing the coding and revising and editing. And the thing I think is really great with coding is this idea that you can have instant sort of feedback. You're not waiting to turn in your story to a teacher to have them edit it or waiting for a peer to do peer review. There's a constant process of trial and error and of self-revision because it either works or it doesn't work with the coding, and you constantly can try and tweak the language, tweak the coding process and your instructions to see if they're working. But you can also bring in this idea of peer feedback and have other students look at the code as well as the story that they've coded and make suggestions for things that the student might do to improve their story. This can be done in a variety of ways depending on what apps you're using. You can do a gallery walk is one way I think works very nicely, is to have students actually have their devices up so that they take turns, and part of the class will move through the different stations and make comments, and then they'll take turns and they'll be the one showing their codes or programs off and get the feedback. You can also have this more formalized where students actually go in and look at each other's as they've been shared. Particularly if you're working on Scratch on the computer, this is easy to do. But I think this really brings into the idea of the collaborative process. And I know Kate often talks about within the programming world, and I like adapting it for a variety of ideas, is this idea that you actually ask 3 than me. So that if you don't know how to make your sprite talk when it bumps into another character, then talk to some other coders in the room and ask 3 other students, and if you still need help, then come to the teacher. But it really empowers students to become the experts and to be there to help each other. I talked to a teacher last year after doing one of these webinars, and she actually had started including helping others and collaborating as part of her classroom participation in the grades. And I love that idea that part of your classroom participation was how well you had actually helped other students. And the final process then is that peer, is that publishing and of creating a learning community of coders. One of the things that's really great with a lot of these apps is there's options in terms of how you share, and you can either share to the larger community. So for instance, this is also this is actually Hopscotch, and you can publish directly to their community. You can also do that within Scratch as well, or you may actually just publish it in a way to share it within your classroom. So there are different options in terms of how you share it. But I think one thing that's really exciting for students is if you have that ability within your district to share with a larger community, the students really have that authentic audience. And there's nothing more exciting than to see the number of views or likes or remixes where other students have actually taken their code and built on it. I think that can be very empowering for the students to have that option. Kate, do you want to?
Yeah, we just, people are saying they like the storyboards, and I was going to say that even when I create one of my websites for EdTech Teacher, I will find myself a lot of the time actually using Post-its and note cards, because for me, I'm interested in navigation and how people use the website. So I will find myself even physically putting down Post-its or index cards to navigate through a website and organize my website before I even actually ever start sitting down to make a website. I think storyboards are really important visual of seeing something that will eventually be very digital. Just because it's coding does not mean that it needs to be necessarily paperless or, without just entirely in front of these devices. So now we'll transition a little bit here to some the technical sides of this. Like, how do you actually, what does this look like? Maggie and I actually presented on this exact topic at our iPad Summit 2 weeks ago in a what we call an innovation lab, which is a hands-on opportunity during our conference. So I'm going to show you what we did, and it's very iPad specific, but on edtechteacher.org in our apps recommendation section, we have a whole coding page devoted to, if you click on each of these apps, they'll give you recommendations. If you click on at the top these blue circles, that's for the different devices. So iPad, Chromebook, laptop, and Android. So you can find what's great for you. When it comes to digital storytelling, what you need is an app that is open-ended. So a lot of these apps like Codable and Lightbot and Daisy the Dinosaur and Bebot, they are just sort of games. So they're sort of levels and you get through them, but something more like Scratch Junior or Hopscotch is more open-ended, and it creates these templates and a medium for which students can create their digital stories. Scratch is, like we mentioned, created by Mitch Resnick, is only works on a laptop or Chromebook. It's web-based. It does not work on an iPad, but there is Scratch Junior, which is a much more simple version. So I say that, like, if you need somewhere to get started and you do have iPads, K-3 iPad Scratch Junior is great. Very simple, few buttons, cognitively pretty limiting in their options. So therefore, it's great for when you're getting started. Hopscotch adds a whole nother level of complexity that you can do. Sort of when we think about those cups, when you're doing the Robot Friends activity, Hopscotch is when you start flipping the cups and adding a little more color, but you can also make it very basic. So it's great for sort of the middle school age and honestly up through high school. If you, both apps are free, and so they're really, really fun to play with. And Scratch on the computer. High school age, I didn't include them, but again, Hopscotch can really be used, and Scratch itself can be used at the high school level very easily. Like we said, the slides are below. These are actually links to our tutorials for the iPad. So I've created these step-by-step tutorials for Hopscotch and Scratch Junior. But the other great thing about these two apps, and including Scratch on the computer, is there's great communities around this, and these apps have amazing tutorials and help and forums themselves. So there's a lot of support out there. But normally the best way to do it is to learn is just to learn by doing and see how other people did things, and then you have the ability to look into the code or remix it. And that's really what technology is. I don't sit down with a blank screen when I need to make a website and start plugging in that syntax that we showed you before. I start with a template that someone else has already created, and someone else has all lay the foundwork, and then I customize it to what I need to do. And that's essentially how the new iPhone doesn't come out by not starting with previous iPhones and what they've learned. So that's sort of it's a great way to learn, is by also seeing how other people have done it. And so we're talking about this analogy to the writing process with coding, and how it's something that students are already used to. So in the classroom, we have the pre-writing process. Well, the next thing you hear teachers say, well, I don't know, how am I going to teach my students how to use these apps? So we like to, at EdTech Teacher, do everything in a challenge-based model. So learn by doing. And so these are sort of these small challenges that you can set up that's part of the pre-writing process, but is also introducing them to the apps. So if, say, you were using Scratch Junior or Hopscotch, or you could do Scratch on the computer, and you choose one of these two apps, you first have to start your project, and then you give directions that basically lead them through this. So create one character on one side of the screen. This will be character A. Create another character. This will be character B. And then you can have these bonus challenges, because in Scratch you can actually turn the camera on yourself and put yourself in as a character. And one thing that I was taught by a fourth grader was you can create, Hopscotch only has a certain amount of characters. However, you can also insert text. Therefore, if you insert emojis, you have now created a whole nother wealth of characters that you can bring into your story. So that's sort of a fun way. So first you create your characters, and then you create the background. So where is your story going to take place? How are you going to make that background? Hopscotch is a little more complicated than Scratch Junior, where Scratch Junior, you can draw your own background, insert a picture. They have some standard ones. Hopscotch actually starts with a totally white screen. So if you want a background, you actually have to program the background and draw the background. And what does that mean, and how does that look like? Hopscotch kind of has a standard one that you can see how they do it, but it starts to introduce that process. And then the next challenge is create movement. So you want to have your characters do something, right? They're in a story. So here's how you can, through the apps, are just these simple drag and drop buttons that you lay the sequence. Instead of just those up, down, left, right arrows that you might have had with the cups, there's a lot more options, and you put them in these orders to make this happen. So if you can see the GIF on the right here moving, I made myself a character, and I walk up to the cat, and I make onto the fourth challenge, which is have them have a conversation. And by having them have a conversation, you have to start thinking through the process of, well, how do I make text appear? And how do I make sure the text is not appearing when it doesn't need to appear, and it appears in the right process? So as something like Hopscotch, you can do certain things where I have in my code in this one, when the elephant bumps into the cupcake, that's when the text appears. But before that, the text is set to invisible. And then the text appears when this happens. So you have to think through, they have these very basic, in the coding world, it's sort of called if-then statements. If this happens, then do this. And in Scratch, it's the same way. They do it with messages. And you sort of can, so through these 4 simple challenges, you've already been able to set up a scene. And another way of also thinking about it is the writing process, but you're also basically a director, and you're directing your actors to do and say what you want to do. And just like in the theater world, they have what's called blocking, where you have to, that's essentially programming. So, so this is another example of the challenge. And then there's a bonus challenge, because Scratch actually allows you to import audio, which is great for if you are doing this with kids who are not writing yet. You can just have them insert audio. So when something happens, something that they say pops up. Hopscotch, you cannot bring in photos and you cannot bring in audio. It's just within the app. So finding the right app that will work for your situation, or what's great about technology is giving your students options. So once you've created these beautiful works of art, we get asked all the time, okay, now what? Originally, I actually didn't recommend Scratch Junior, because Scratch Junior used to only live on the iPad, and only on that iPad that it was created on. You couldn't do anything with it but look at it on that iPad. And they have now added some features where you can actually share it, and you can save it to Google Drive. It's not very obvious how to do that. In the tutorial that we included, there's sort of the more how-tos, and please always reach out to me if you are interested. I'm happy to walk you through that process. But using something like a Google form, where someone, all these applications always create a link to view it. Even if you can get a link in Scratch Junior, you can get a link in Hopscotch, you can get a link in Scratch. Normally it means you can only view those programs or finished products within the app. So unless you have Scratch Junior, you won't be able to view a Scratch Junior project. Unless you have Hopscotch, you won't be able to view it. There's no other export features. And the reason for that is that in our case right now, where we're just creating digital stories, we can create these little videos. But in reality, you can also have things happen where if I tap the screen, do this, or you can actually have stories then be interactive. Think Goosebumps, and that's what I think of interactive stories, but you could actually create these really dynamic stories where there's actual interaction where, should I go through this door? Should I go through that door? And then what happens after that is all possible with some of these apps. So that's why it can't be exported as anything but these programs. But if you do want to create mini videos for publishing and sharing, it is possible. It is a little bit cumbersome, but I thought I got this question last time during the summit, so I thought I'd at least sort of share. This is how I did it today with my cousin's Thanksgiving piece that she made. With an Apple, if you're running Yosemite or higher, you can actually plug in the iPad and run QuickTime, and you can actually get a screen capture of your iPad. If you're using a laptop, then you could use one of your favorite screencasting apps. I have a link there to all the different ones that we recommend, whether you use QuickTime or Screencastify or Screencast-O-Matic. There's lots of other ones. So, and then what I did, as you saw in the slides here, they sort of were moving around. You can create these free little GIFs where you create the video, you upload the video, and then it creates it a GIF. And a GIF is actually an image. So anywhere you can put and share images, you could have this little short app. GIFs, though, do not have audio. That would be the only, if you were doing that. So that's sort of the technical side behind how can you actually make these work. Maggie mentioned Tinker. Yes, Tinker is great. Tinker takes Hopscotch to the next level as well. It has physics parts in it. It has math in it. It's really robust. So I'd almost say it's sort of the app to unleash those kids who need the next thing and are going on, because I would say maybe let's just say there's 30 options for Scratch Junior, and then you've got programming options of upwards of 50 something for Hopscotch, and then into the hundreds when you start adding in the Tinker. So and that's kind of what Scratch on the computer is like too. Maggie, do you have anything else to add about that?
Yeah, I was just saying, if you want to let me, I had pulled up a couple things just to show people how they could explore a little bit with both Scratch and Tinker on the computer.
Yeah.
All right.
What's also, Tinker starts with a game too to introduce you, which that's what I sort of love about it. You're like, oh, I have to play the game, and I play the game, and then it gets you into, do you want to make your own game? Because that's definitely a big, to get kids into coding as well. Kids love to play games. 97% of kids play games on devices and things like that. So that's just another way of getting them hooked on it.
Yeah, just a couple of you guys were asking in the chat wing about Tinker. And this is Tinker on the computer. It is available free as an app on the iPad as well as free on the computer. You can see it is very graphically attractive to students. It looks very much like computer game / animated video sort of thing. So you'll notice this is specifically for their hour of code. They created a whole series of games that you can explore from kindergarten all the way up through high school. You'll notice they're also beginner, intermediate, and then sometimes advanced ones here, for instance, the activities that you can have. So there's a lot of different activities that you can do, but you can also explore their different published examples. And so, for instance, here are 3 that I searched for stories that students have tagged as stories. And what you can do if you click on one of them is you can actually see the story happening as they've coded for it. But the other thing that's really cool about Tinker as well as Scratch is if you look here, when I hover over one of the stories, I have this option to remix. And Kate was talking about being able to look behind the scenes and see what happens in a story. And if I click on the remix, what it will actually enable me to do is, we'll see our little Tinker monster thinking for a bit, but I can actually see the code that went in behind the scenes to create this story. I can see all the different actors, I can see the stage, I can see how each actor was coded so that I understand how this programmer created this story. This can be so I can edit and remix it myself, or so that I can use this to help me as I'm creating my own story so I can see behind the scenes what they did. The same thing is possible within Scratch. Scratch actually has sample projects that you can, thousands of projects actually, that you can explore. And if you look at this, this is a project board that a teacher created a while back, but highlighting several different examples of storytelling that she found that she wanted to point her students to so that they could see examples. And if you look at, for instance, this one on caring for a puppy, I can click on it, I can see it happen, but I can also, so I can click on it and actually watch it as it goes through. But I can also see inside of it, and I can see the actual coding language that went into the process of programming this story. So those are two really robust programs that you can use, particularly as your students become more interested and more advanced in their skills, that you can help them kind of really unleash their creativity.
Yeah, thanks for sharing those, Maggie. I was just saying that we're pretty much wrapping up here. So if anybody has any last questions, we're happy to stick around and answer any of them. As we mentioned, there's a lot of great apps out there for getting into coding, and you can sort of find what works best for you and your students, and also giving your students that option. And you'd be surprised sometimes what they'll come back with as well. Just a little plug here for any of our upcoming events. We just had our summit in Boston. This Saturday we'll be in Medfield with Google Jamboree, and then we're really excited to be in San Diego in February. We're actually going to have both our iPad Summit, our Google Jamboree, and a new Innovation Summit all happening at the same time. And one registration gets you in all three. The call for proposals is actually due tonight at midnight. We'll be selecting them tomorrow. So sessions should be getting posted here by the end of the week. And that should be a really fun event. I probably will be doing something very similar to this, again, presenting along with Douglas Keong, who's one of our colleagues who works at Punahou in Hawaii and teaches computer science. And he has even great ideas of how you can approach coding from a design perspective. And I believe we actually have a webinar on our website from last year about coding by design and how you can approach coding from another perspective. And then I think we have I think my last slide is that we also have a bunch of other webinars coming up. So thanks for joining us this afternoon, and from all over the country and world. And feel free to share these resources out. They're not going anywhere. And feel free to reach out if you have any questions.
Yes, I would encourage you all. Both Kate and I's contact information was on the very first slide. EdTech Teacher makes it simple. It's kate@edtechteacher.org or maggie@edtechteacher.org. And we'd love to hear from you and love to help you get started with the digital storytelling and coding with your own classes.
And thanks everyone for joining us. Maura says she's going to do the PBJ and solo cups examples with your students. That's great to hear. So it starts with just a little bit of a step, and you'd be surprised to see which students will also just grab the reins and be teaching you things soon. So I'll hang out for a couple minutes in the chat in case anybody has any last minute questions. Otherwise, have a great rest of your day and happy holidays.
Thanks. Bye.
Bye.